Hello, I'm Robin Vincent and welcome to Molten Modular. Today I'm revisiting the whole idea of DC coupling and using your computer to modulate your modular. Now, in the starring role of the thing that enables this to happen today is the Ferrofish Pulse 16. The Pulse 16 is an A to D, D to A converter. It's an ADAT box. It's got ADAT ports at the back and then analog ports in and out. The idea is that it takes in analog sound, normal sound down chat cables, turns that into ADAT light pipe and plugs it into some other interface. And then it does it the other way around. It takes audio out of your audio interface over ADAT, plugs it into the box and comes out in analog audio. It's a conversion box. It's not an audio interface. It doesn't plug directly into your computer. You need to have an audio interface which has an ADAT connection in order to make it work. So for this demonstration, I'm using the Arturia Audio Fuse. It's the only interface I've got knocking around that has ADAT on it. I have the Audio Fuse hidden over the back here. Here it is, and this has ADAT input and ADAT output on the back. They're attached by these two light pipe cables. Now, I know they look different, but these are actually the same. They're just cables made slightly differently. And what it carries is the light of an ADAT connection. So we've got the output from the Pulse 16 going through this cable as optical 8 channels of ADAT into there. And then I've got the output from the Audio Fuse, which is going to carry our DC coupled signals of 8 channels coming out of here down this light pipe cable and in to the Pulse 16. So both of those carries 8 channels digitally from this device to the Pulse 16. And it's the Audio Fuse that's connected to my Surface Pro, which is here. It's not an iPad, it's a Surface Pro running Windows. And what the Pulse 16 is doing is providing or expanding the inputs and outputs into the Audio Fuse. So potentially I have 16 inputs and 16 outputs coming from the Pulse 16. However, the Audio Fuse only has the one ADAT in and out, so I'm just going to be using 8 channels. But what you can do with those 8 channels, or 16 if you have an interface of more ADAT ports, is quite remarkable, and that's what we're going to be talking about. Because the Pulse 16 has a particular key feature which not everything has, and that's that the outputs on it are DC coupled. What does that mean? Now, DC coupling refers to your audio device's ability to pass control voltage. Now, control voltage is just a signal. It's exactly the same as an audio signal, except that it's moving very slowly. Usually. Sometimes it isn't. Sometimes control voltages can move up into audio rate. But the point with control voltages is that you are sending often a flat or slow moving voltage. So it's the sort of thing that goes between modular modules. So if I want an LFO, a low frequency oscillator, to control the cutoff, I send a slow moving waveform from one to the other down a patch cable, and that creates the controlled voltage modulation. Yeah? That's great. However, in audio systems, there's a problem, because in most audio systems, you build in a filter which takes away low frequency sounds, because you don't want rumbles or things that are going to pop your speakers knocking around in the audio signal. It's essentially noise as far as audio is concerned, and so you filter that out with a high pass filter. Most audio interfaces have these, and that's great, and that's normal. However, the flip side is that you are therefore unable to use that audio interface for control voltages. Why would you want to do that at all? Because your computer, through software like Bitwig or Reactor or Ableton Live, can generate control voltages to control your modular. And those voltages can be generated directly within the program and sent out of your audio interface. However, if your audio interface is not DC coupled, it will just not work. It will filter it out, and you won't be able to successfully do it. So if you have a DC coupled audio interface, that means it doesn't have that filter and it lets those signals through.
Now some audio interfaces have this. I've made videos on the Native Instruments Complete Audio 6 and on the Motu M4. Both of those have DC coupled outputs and provide the ability to send control voltage out of those outputs and into your modular. I've done videos, go and check them out. I go into a lot of detail of what that's all about and how that works. For this video, I'm showing it on a grander scale with this box, the Pulse 16, because every output is DC coupled. So I have potentially 16, although I'm only actually going to use 8. 8 outputs, DC coupled, taking modulations and manipulations from Bitwig, or Ableton Live, into my modular. That's the idea. But I have an added bonus with the Pulse 16 in that it also has all of these inputs. So I could take a whole lot of outputs from here, for instance, and jam them in the back of this to do multi-track audio recording of my modular into my computer. So it's a double whammy. I get control going one way and I get audio recording coming the other. Now the Pulse 16 doesn't actually have DC coupled inputs. So what I can't do is run a load of software on here and try to control it from the control voltages from my modular. It won't go that way. However, it's a lot more common to go the other way, to take modulations from something like Bitwig and stuff them into your modular. I'm not going to go into masses of detail about what DC coupling is or how it works and all those sorts of things. I'm just going to demonstrate how well this box works, how to do some of the stuff and what to look out for. So first let me show you how it's all connected up.
This one is the back of the Pulse 16. There's the ADAT connections. There's more ADAT connections that you can see there because it is a 16 channel device. And then here are the analog inputs and outputs. So these top 8 channels are inputs, and these are coming directly from the modular, going into that, being converted into ADAT, ADAT going into the audio fuse. And then the CV modulations are coming out of the audio fuse, out of the computer, into the Pulse 16 and converted into this bottom row of analog, which is carrying all of the actual control voltage on these cables here.
Now when you're using DC coupling out of an audio interface, let's just assume that this is an audio interface. Even though it's not an audio interface, it's just providing the interface to the audio fuse via ADAT. I explained that, right? Yes. However, the concept is the same because essentially the Pulse 16 has become an extension of my audio interface. Got it? Good. So the first thing you need to get over with DC coupling is that it requires the right sort of cable. Now the outputs of the Pulse 16 are all balanced, TRS balanced, very, very cleverly balanced, brilliantly balanced out the back. But balanced outputs for DC coupling are actually of no use at all because we're trying to get it down to this, to a single little patch cable. That's what we need. We need the signal coming out of that, and that's just TS. It's not tip ring sleeve, it's just tip sleeve. That's what we're trying to get down to, and so for that you need the right cable. And what you can't use is just one of these with an adapter. Well, you sort of can, but it's not going to give you the full thing. Let me show you. I have to explain this bit because it's important. So bear with me before we get onto the big demo. This bit is really important to understand. Now in Bitwig, I've got all these LFOs set up which are sending stuff out of the Pulse 16. You can see all these 8 channels here go crazy. This is the beauty of the Pulse 16 and its connection to Bitwig in particular. As in Bitwig, you can just create LFOs like this, specify the output that it's going to, and off you go. Simple, brilliant. I've now got 8 channels. 8 channels of LFOs all pouring out of here. LFOs out of here, out of here, out of here. Fantastic. But let's not get ahead of ourselves. Let me show you what I mean about the difficulty in using regular patch cables. So I'm going to find number 1 on this. Number 1, there we go. There's number 1. See, look, I've labelled them up beforehand because I'm so organised. I'm going to plug this into my scope over here, and you can see a lovely LFO. A lovely LFO. I've not plugged it into anything else. We're not hearing it doing anything, but we have a lovely LFO going on in my display there. Now this is using the right cable. So let me show you what happens when I use the wrong cable. So this is a regular patch cable, put an adapter on the end to make it jack so that it plugs into the back of here, because this is all 1/4 inch jack in out at the back. I'm going to replace that cable with a patch cable and then plug that in instead. So we now find that we've lost the top of the waveform. Now if you've seen my other DC coupling videos, you'll know that what we expect to happen here is for you only to get sort of half a waveform. Because you'll plug in a mono jack into a balanced output, you can only really access half the signal at a time. And so you get either the positive part, and then flat, or the negative part. Oddly enough, with the Pulse 16, we're getting both halves, but it's being flattened at the top. Now I can't exactly explain this. I did get to speak sort of third hand to some Ferrofish engineers, and they gave me a whole load of stuff which I didn't fully understand, or didn't seem to feel it was entirely relevant to my question. But it's one of those things where the brilliant engineers who build this stuff don't necessarily use it for this sort of thing. At least I'm finding, certainly with DC coupled stuff, I very rarely get to speak to anyone at a manufacturer who's manufacturing the interface with DC coupling outputs who has actually used it for such a thing. And so they go, we don't really know what you're talking about. But it doesn't really matter, because it's relatively easy to demonstrate. The point is that if you use a standard patch cable out of the back of the Pulse 16, it's not going to give you your full waveform. However, you're going to get most of it, and that's pretty awesome. Let me plug one of these in alongside, again, the right cable, which I'll tell you all about in just a second. And you can see the two compared. Okay, hopefully you can see that. The green line is the one coming through cable number 2 here. And the red line is our one with our regular patch cable. So what I could do in Bitwig, I could reduce the swing, or the amplitude of that LFO, to see whether it can hold an entire signal down a regular patch cable. So I've currently got that set to like 100%. So if I bring that back to say 80, you can see in the scope that we've now brought back the entire waveform. So while it's not going plus and minus 6, it is doing us, it's doing us about 5 and a bit volts, which is actually plenty. So what I've discovered, oddly, with the Pulse 16, because I didn't expect it to work like this, I expected absolutely to get the top half of the waveform and then cut, top half and then cut. But I'm getting a good plus or minus 5 volt swing of an LFO through a regular patch cable. That shouldn't work, but it does. So perhaps the right cable that I'm about to tell you about is perhaps not as necessary as it is with other interfaces. Because again, if you look at my DC coupled video from before, that is absolutely what I'm having to do. I'm only getting half a waveform, so I'm having to sort that out by getting a different cable. Put this back to single so that you can see it a little bit more. And then if I bring that level back up again, you can see that as soon as it hits 5 volts, it flattens out. Now, there's another way I can fix it, just as an aside, and that's by sort of pulling it out a little bit. So if I pull it out a little bit, there we go. So I'm essentially crossing the streams. I've pulled out the jack cable on the back, so it's no longer fixed in there. It's just sort of floating a little bit, and it's now connecting to both channels of the TRS balanced output, and it's giving me a proper waveform. That's great, but then this isn't particularly secure. So what is this right cable I've been talking about? Well, the right cable is called a floating ring cable. And essentially it's a cable that's properly made up and designed to do the half pull out bit. So it crosses both sides, the positive signal and negative signal of the balanced signal coming out, and puts it all together so that we get a complete waveform. So a floating ring cable looks like this. It's got tip ring sleeve, as you can see, and on the other end it's just a regular mini jack patch cable. You can get these from Thonk and other places like that. They're not massively expensive, but also they're not like the most awesome cables you've ever seen in your life either. However, they're only carrying control voltage, and so this is absolutely fine. And at about 1.5 meters, they seem to be plenty long enough. And so for the rest of this video, I'm going to be using proper floating ring cables, because I bought 8 of the buggers in order to do this video, so I'm bloody well going to use them. So with all the explanations done and got out of the way, I hope you understand all of that. Let me demonstrate the sort of thing you can do with Bitwig through the Pulse 16 into my modular. Let's start off plenty simply, shall we? So I've got number 1 here. Number 1 is going to go into the cutoff on this filter. So how I've connected this up is that I've taken 8 channels of audio out of my modular straight into the Pulse 16. It's not on anything special, it's just a mute-on, which is essentially a muting VCA. Here I've got 8 different channels going in, and the out is going on this bunch of lovely cables here, as you can see, 8. All the way along here and into the back of the Pulse 16. You can see all the analog inputs here are all bouncing away. You can't hear it because I haven't turned it on. If I turn it on, now it's an absolute cacophony mess of stuff, because I've just got a load of stuff going through and going on. So let me calm this down a little bit down to perhaps one thing, and we'll come back to the multi-channel mixing and recording in a minute when we've sorted a few modulation issues out, perhaps. So I've got this. So as my first demonstration of what on earth's going on, I'm going to take the LFO, which is pouring out of here, and I'm going to jam it in to the cutoff of the filter. Now how much LFO is being applied to that filter, I have adjustments on the filter itself. So it has a full range of LFO coming out of Bitwig. But I've just calmed that down a little bit. But while that's going along, let me just show you what you can do in here. Because Bitwig has this very clever CV engine, which allows you just to take this CV device, it's just a knob which generates control voltage, but you can plug in whatever modulators you like. So I've attached an LFO to it, and the LFO has various things I could do. I can change the shape of it. In either direction. I can add delay to things. I can change the phase or the size. And I could bring in other modulators to modulate that, if you know what I mean. So I could add another LFO, for instance. And I could take that and apply it to this thing here. And I'm going to slow this LFO down. So as you can see on the waveform in Bitwig, you're getting this changing LFO going on because I've applied this LFO to the amplitude of the other one. That's really easy. I could add another modulator. Now this is a steps generator. I can take that and apply that to something as well. I might apply it a bit to that. And you can do various things with various devices in Bitwig and just keep adding them in either to control the same one or to control different ones. So for instance, this is a good one for perhaps doing something individually. So for this one, I'm going to get rid of that LFO and I'm going to add that steps back in. I'll put a load of modulation in, and I'm going to send this out of ADAT2. So channel 2 coming out of the pulses, number 2. I'm going to plug that into the resonance. In order to apply the steps to the resonance, I need to map it. So I click the flashing button here, and I move it to what it is I want to move. I'm going to move to number 3, and I'm going to plug this into something else. Number 3. I've got another sequence coming through from the Honor VCO up here, and I'm going to plug this into the filter. You can hear that going already. But let's give that something else. So if I add a random to it, again, I can combine it with an LFO. So very quickly and easily you can build up a whole raft of modulations coming from Bitwig directly into your modular. But that's not the only place you can do it. You also do it in this thing called the PolyGrid. Now this is an entire modular environment within Bitwig where you can build whatever you like. It's got all sorts of different modules. It's got mass, randomizations, modulators, delays, mixing, filtering, oscillations, data management, displays, all sorts of stuff. And you can create within here any sort of modulation you like. So I've got a modulation, got an LFO here. It's been patched to this particular output, which in this occasion is ADAT number 8. And that's being used as a clock so that we can clock the whole thing to the computer. I then got an envelope here going to channel 2. Here's channel 2. Which is being triggered by this gate here. I've taken channel 4 to use as a transposer for the quantizer, the microscale I've got up there. And this one I can do at a touch of a button. So both the modulation devices available within each track in Bitwig and the PolyGrid give you different places in which to generate control voltage to send out of something like this. It's enormously powerful. You can have all of these different patches set up within different projects within Bitwig or within simply different tracks. I mean, I've got all this modulation here on one track. I've got all the PolyGrid on another. It could all be on the same one if I like, but it could get a bit confusing. You've got lots of things going on at once. So putting together lots of CV outputs together on a single track just allows you to manipulate the heck out of it and recall it and change it and all that stuff. It makes your computer enormously useful within the modular environment. I mean, it's not the same. You haven't got the same hands-on knob control, so it's a hybrid setup. It's a slightly different way of working. You might prefer to stick with all your hardware, which is fine. I kind of tend to, although whenever I sit down with something with a DC coupled audio interface and start messing around in Bitwig, the amazing power that's available within here just becomes very evident to me. Of course, many people say, why not just use MIDI? Use a MIDI to CV converter. Yeah, you could do that. You can do everything via MIDI and send it to a module which converts that MIDI into control voltage, and that can be simpler in a large number of cases. However, what you don't get with that is what control voltage is brilliant at, which is the blending of it, the manipulation of it, the crashing into one another, the unintentionalness of it. MIDI is very intentional. You've got to know it's on, it's off, you've got a controller, you're drawing in a line to do a little bit of automation. Yeah, it's very, very deliberate. With control voltage, it's like just simply here, I've got two LFOs going on. One is messing about with a knob differently to the other one, or one is controlling some aspect of the other one. It's that interplay of control voltage which is interesting, and that is what's then coming out of the back of this at a massively high resolution and is going directly into my modular to control stuff. Now the other side of all this is the fact that I've got 8 channels of audio coming back into the Pulse 16, and within Bitwig and any other DAW for that matter, I can record that as multi-track audio. So I mean, very often when I'm doing jams or making music on my modular, I just end up with a stereo mix, and that's kind of what that's good enough. Putting that up with a video, that's fine. But once you start introducing multi-track recording, you suddenly realize that you can put individual oscillators or individual voices onto individual tracks, and then you could actually do a bit of mixing later, so you don't have to do it all on the spot. You can go back and start panning it around the place. I mean, panning, for heaven's sake, within a modular? What? So yeah, you could do that. You could add reverb and effects and delay to different tracks at different times. You can actually bring stuff in and take stuff out. There's, you often find yourself when jamming on modular, you just got everything going all at once. But if you want to then sit down and create a bit of a track, it's going to make sense to blend stuff in more, take stuff out, bring stuff in. That's good. That takes your modular to kind of another level, really, because you put some afterthought into it. It's not just all in the moment. And that's the beauty of the Pulse 16. I've got all these DC coupled outputs that I can jam in for extra modulation, and I've got all these inputs for recording multi-channel audio. Now, I'm sure people are saying, oh, well, you've got to come out of a proper audio interface. You've got to have something which converts the hot Euro-rack audio into audio that's good for an audio interface. Yeah, maybe, but honestly, I've just plugged it all in and it seems fine. So, don't get hung up on these things. Honestly, it seems fine. So if I go back to my audio fuse monitoring here, just going to turn off the output for the moment. I'm just going to bring everything back in. I've got levels coming up here on the different ADAT channels. I've put in 2 stereos. So I've got stereo coming out of the magneto and stereo coming out of the beads here. And all of it is at a decent level. It's not distorting. And I can record it directly into Bitwig. Let's do a little bit of that. So I'm going to enable all these for recording. One tip though, for if you're creating an audio channel for modulations, take off the audio output, the monitoring audio output. You don't want to be able to hear your modulations through your audio interface, if that makes sense. You don't want an audio out. You're sending the audio outputs through these CV devices within that audio track. You don't want to hear it mixed into the rest of your output. You just want the modulations coming out and the other sound from the audio tracks. So when you select that track, which has got all this stuff in it, I've got this set to no output, because look, it's generating a load of stuff from this whole chain of devices. And I don't want to listen to that in my mix. You with me? Right, so everything going on. Let's see if I can calm it down a little bit and then do some multi-track recording. So I've still got modulations coming in out of Bitwig. Not everything, because I haven't quite worked all of that out. This is just a demo. So if I hit record in Bitwig, that'll all start going crazy. Cool, job done. Job done. And the awesome thing is that when you then play back, I can then start to mix it about. Although obviously you do a much better job than me. But I hope that you get the idea. I hope you get the idea of what I'm trying to put across here, which is, if you pardon the cockerel, which is that the Pulse 16 provides this expansion to your studio. It provides this avenue of modulation into your modular, and it provides multi-track recording of that back in. I mean, obviously so. Yeah, the key thing being the DC coupled outputs on this that opens up the entire world of modulation. You don't have to use Bitwig, you could use React, you could use Modular, you could use Ableton Live. You know, any piece of software which supports control voltage generation, you can use the DC coupled outputs of the Pulse 16 to stick it and infect your modular synthesizers and analog synthesizers and anything else that responds to control voltage. As for the Pulse 16 overall, it's just a beautiful piece of gear. It sits there, it does its thing. These displays on the front are beautiful and useful because you can see that something's happening when you're struggling to get the sound out or trying to get the modulation in the right place. It just sits in there. I haven't had to fiddle with any of the settings. Just need a cable, ADAT in, ADAT out between this and your audio interface. And you're sorted. You might need to mess around a little bit with the clock settings. I find, particularly with the audio fuse, that you need to set the clock to the ADAT device. You can use an internal clock, the audio fuse has one, and then use that to clock this. What is this clock I'm talking about? Whenever you're using ADAT, digital light pipe, the digital engines of the two devices have to be locked together, sample locked if you like, otherwise you get crackling and other nonsense. This isn't to do with clocking your modular, that's a whole other thing. This is digital clocking between two digital devices. And in my experience, setting the audio fuse to internal, it just doesn't quite lock right, and you get clicks and you get pops, and it's just not completely happy. However, the clock on the Pulse 16 is absolutely rock solid. So you use this to clock your audio fuse or your audio interface, whatever you're using, and set the clock to external ADAT, and it will get just rock solid. So that's a quick tip for you. Otherwise, drop it in, It works. It's amazing. And it is an enormous amount of fun. And please don't judge it on the level of my manipulation talent, the amount of time and the awkward situation I'm in trying to sort this out while demonstrating it to you. I hope that's useful. Do go and check out my other videos on DC coupling if you're interested on getting right down to the nitty gritty of what things like Bitwig and Ableton Live can do. This has just been a bit of a demonstration to put forward the idea of multi-channel DC coupling through something as awesome as a Pulse 16 and multi-channel recording back in. There you go, that'll do. In the meantime, go and make some tunes.